Hi friends, in this session we study about the standard deviation. The standard deviation concept was introduced by Carl Pearson in 1823. It is by far the most important and widely used measure of studying dispersion. Its significance lies in the fact that it is free from those defects from which the earlier methods suffer and satisfies most of the properties of a good measure of dispersion. Standard deviation is also known as the root mean square deviation for the reason that it is a square root of the mean of squared deviation from the arithmetic mean. Standard deviation is denoted by the small Greek letter sigma. Here I would like to explain you different methods to find out the standard deviation for different sort of series. Look at in this table, you see there are methods, the direct method, indirect or shortcut methods are there. First is assumed mean method in shortcut method, other one is step deviation method. For raw or individual series, raw data or individual series, we have sigma, which is the standard deviation, is equal to the square root of summation of x minus x bar whole square over n, where x bar is a mean. Here you see in the assumed mean, if you have to find through the assumed mean, so the raw data or individual series, if we find through the assumed mean method, so sigma is equal to square root of summation of dA square over n minus summation of dA over n whole square, where dA is the deviation from assumed mean of the data, which is x minus a, or a is the assumed mean here. Now if you have to find out the SD through step deviation method of raw data, then we will follow this one formula. Sigma is equal to square root of summation of di square over n minus summation of di over n whole square, then multiplied by I, where I is the SCF of dA, highest common factor of deviation from assumed mean. So this is the formula about raw or individual series. Here you see in ungrouped and grouped data or the discrete data, if you have to find the standard deviation for this, for direct method we use sigma is equal to square root of summation of f into x minus x bar whole square over summation of f. For assumed mean, sigma is equal to square root of summation of f dA square over summation of f minus summation of f dA over summation of f whole square. For step deviation, sigma is equal to square root of summation of f di square over summation of f minus summation of f di over summation of f whole square, then multiplied by I. So these are the methods by which we could easily find out the standard deviation of different sort of data. So here I will explain you this with one of the example. I would explain here in this session direct method of raw data. So we will solve this question through the direct method. These are raw data we have. Calculate the standard deviation from the following observations. So you look at here, the observations are 240, 260, 290, 245, 255, 288, 272, 263, 277 and 250. So here first of all we have to write down these observations in a table form. So here we have to make the table, we have to make the column. 4 columns I have made here. Look at here, the serial number 1 2 3 4 5 6 7 8 9 10 data we have, and these are the value x, the data whatever is given to us, 240, 260 and so on. So for this, if you see the formula for this, here I have written this formula. Sigma is equal to square root of summation of x minus x bar whole square over n, where x bar is a mean. So first of all we have to find out the x bar. So for x bar we have a formula. I explain you first this formula. So for x bar is equal to summation of x over n. So first of all we have to find out the summation of x. So summation of x, we have to calculate these all x here. So we calculate this first. It is 0, 5 plus 5 2 plus 8 18 plus 2 20 plus 3 23 and 7 30. So I will write here 30, 3 carry, 3 4 7 6 13 9 22 4 26 31 39, 39 and 7, 46, 46 and 6, 52, 52 and 7, 59, 59 and 5, 64. So we get here 4 and 6 carry. 6 plus 2, 8, 8 plus 2, 10, 12, 14, 16, 18, 20, 22, 24, 26. So we have got here 26. So it is 2640, which is summation of x. So first of all we would find out the mean. So x bar is equal to 2640 and the total number of data, which is 10. N is 10 we have. So we'll put here 10 and we get here x bar is equal to 264. This is our x bar. So what we have to do here? So we will find out dx, which is x minus x bar. X is 240 we have, and we have to subtract x bar, which is 264. We have just find it out. So it is minus 24, and 260 minus 264, which is minus 04. 290 minus 264, which is 10 minus 64, and 8 minus 62, 26, which is positive. 245 minus 264, 14 minus 5, which is 9, and 5 minus 4, which is 1. So it is negative now again. 255 minus 264, 14, it is 9, minus 9 again here, that is minus 19, it is minus 9. So it is 288 minus 264, which is 22, which is positive. 272 minus 264, it is positive. 12 minus 4, which is 8, 0, 8, and it is 263 minus 264, which is minus 1. 277 minus 264, which is 3, 7 minus 6, 1, it is plus 13. So here 250 minus 264, so we are getting here minus 14. So this we have got the deviation from mean of this data. Now what we have to do, we have to make the square of this, x minus x bar whole square, or the dx square. So I would write down here the values of square, which is minus 24. If we make the square of minus 24, 576. The square of minus 4, which is 16. Square of 26, it is 676. Square of minus 19 is 361. Square of 9 is 81. Square of 22 is 484. Square of 8 is 64. Square of minus 1 is 1. 13 is 169. Square of 14 is 196. So we have got these all. Now we get the summation of this. So we get the summation of this here. We find out the summation. 6 plus 6, 12 plus 6, 18, 19, 20, 24, 28, 29. 29 and 9, 38. 38 and 6, 44. So we are getting here 44. 4 we are taking here, and this 4 we are getting carry. 4 plus 7 11, 12 plus 7 19, plus 6 25, plus 8 33, plus 8 41, plus 6 47, plus 6 53, plus 9 62. So 2 is here and 6 is carry now. 6 plus 5 11, 11 plus 6 17, plus 3 20, plus 4 24, 25 26. So it is 2624. It is the deviation, square of the deviation from the mean. So now we know this formula. Sigma is equal to square root of summation of x minus x bar whole square over n. So we have to just put down this value here. So I put it down, the values here. Sigma is equal to square root of 2624 over 10. So we get here 262.4. So it is 16.19. 16.20. So this is the standard deviation we have got here. So in this way we could easily find out the standard deviation of any data. So in this way we could easily find out the standard deviation of any raw data whichever is given to us by the direct method. Thank you.